So here's our quick test review. I'll run through the examples here, the problems here, and I'll be referencing this quite a bit, as we can see right now. So this is our layout for how functions are transformed. So if you remember, we can vertically stretch or shrink by the a. It can also flip it over, and it should say the x-axis if a is negative. Okay. Our b's here, they horizontally shrink us or stretch us by the reciprocal, and they can flip us left to right, so that's over the y-axis. Y-axis goes up and down, and so this flips it left to right over that axis. And then our k and our h, you can see what they do. H moves us left and right, always the opposite sign, and k goes up or down. And so if I have a function and I'm going to translate it by putting an x minus 5 in there, that's this x minus h like this. The b value is just 1, and a b of 1 doesn't stretch it or do anything. That's its normal state with a b of 1. So it's just really an h of 5 here, so that h of 5 will go right 5. h's move us left and right. Here I've got an h of negative 13, so it goes left 13, because it's the opposite sign. That's a plus. We use minus 13. And the negative 10, that's like a k value, so this is going to be down by 10. So k equals negative 10, so it's down by 10 units. C here, C is multiplied in front of the function. That is in front of f. In front of f goes the a value. And so a is 100 here. And the bigger a is, the more it is stretched. When the absolute value of a, when it's forgetting about its sign, when the number itself is bigger than 1, it will always be a stretch on the outside. So a here is bigger than 1. It's 100, so it's going to be a vertical. You got to put vertical in there because it's not horizontal. And it's big number, so it stretches by 100. So it'll be 100 times all the y values are stretched by. Let's see here. Keep things organized a little bit here. Here is D now. D, here's my function name, f. I don't know what the function is. Could be linear, quadratic, absolute value. I don't know. I'm just saying in the function, they're sticking in a 1/3 x. Okay, that 1/3 is in front of the x, so that's like my b value. And notice it says by reciprocal, stretch or shrink. So you got to figure out the reciprocal of 1/3. Well, the reciprocal is 3. And 3 is a big number. And by big, I mean it's bigger than 1. Okay, so that's the factor. It's going to be multiplied, the x value, by a factor of 3. And so this is a horizontal stretch by a factor of 3. Just the reciprocal. And then we also have this negative 7 out here, so we need to comment on him. That negative 7 is going to cause a down 7. That's a k value. And then our last two in these little examples here, we got the negative out front. That's an a value that's out front. And that flips it over, I set it up here, flips it over the x-axis. So we call it reflected over x-axis. So that flips it upside down. So let me show you what that looks like real quick. If my function was, for example, a parabola like this, and a was a negative number, it's automatic like this, upside down. Now it could be stretched, like if this was negative 3, for example, it'd be upside down and it'd be stretched by 3. So it'd be narrow and upside down. But this one doesn't have a factor out here other than the negative sign, so it just gets flipped over. On the last one, the negative's on the inside. That's a b value. And b's control x stuff, so it flips it like this. If you had a parabola sitting here on the right side of the y-axis, there's my y-axis right there, it would flip it over to the other side, and it would reflect it across that y-axis, and so it'd show up over here. That's this reflection right there. So we'll say reflected over y-axis. All right, takes care of him. Let's go down here to number 2. All right, And now that we've seen how to do this, I'm going to get rid of that thing. It just kind of gets in the way here. Let's see. I want a vertical stretch by a factor of 7. That means g of x, my new function that I'm writing, it's got to be stretched. So I need an a value in front of the function. Remember, a's cause vertical stretches. So I want 7 times the function. So now I use my notation. It says 7 times what? The function. But the function is 2x minus 3, so it's 7 times 2x minus 3. I just replace f of x with exactly what it's equal to. And then I can distribute that. That's what, 14 times 2, or 7 times 2 is 14x, and then minus 21. There's the new function. Okay. You could graph the original, you could graph g, you would find out that it is stretched by 7. Down 6 units, so g of x is going to be exactly the same thing as the old function, but now I got to go down 6. I got to subtract 6 from it to lower it. F of x, I replace it. It is negative 4x plus 5. I'm just grabbing what f of x is. And it says subtract 6 from that, so it's negative 4x minus 1. That's my new function. Simple enough. And my last one, reflected in the y-axis. I'm going to look up here real quick. Reflect in the y-axis. So there's that. I got to put a negative in for the x. I need a negative x in there. That's easy enough to do. Oops, undo all that. Fix this thing right up there. All right, g of x is the f of, and I got to put a negative x in there. And that will flip it left to right. So let's see here. It says go into function f up here. So here's function f. In fact, I'm going to do this off to the side so you can see exactly how the math is computed. And then I'll show you how you do it inside my problem over here. Okay. So let's say I want the f of, and it says negative x. That is so simple to do. All I do is rewrite the function, but when I get to the x, I put in negative x, because that's what that notation means to do. Then I continue writing my function. And there's no extra work to do here. That's it. I can't distribute the 4 because I have to square stuff first. And I can't square these individually because this is a binomial. I'd have to write it down twice, and do a lot of distributing there. Okay. And we could do that, but we don't have to. We can just stop right there. You know, sometimes on an SAT, they might reverse this so the negative isn't kind of floating out front. But it's a negative x and a positive 2. It's a negative x and a positive 2 still. They're the same thing. But I would just stop right here and be done. So over here, if I was going to do this, I'd just write I'd write 4, because I'm just doing the f of. I put in my negative x for the x, and then my plus 2, and now my math looks like it all makes sense. And this is squared. Over here, my squared on it. And that's my answers. Okay, I'll flip this thing over and do the back side. All right, here's my parent functions. Okay, see here, this one we said the other day was constant. Looks like this if you want to see them. In fact, I'm going to draw all my x, y axes here real quick. Let's see here. X or y is 1. There's the parent function. Remember, that's a horizontal line at 1. Y equals 1. Next one is our linear function. Linear. X to the first powers are always linear. The linear one goes up 1, over 1, down 1, left 1, just like this. It's just y equals x, or f of x equals x. Absolute value function goes to the right up 1 over 1, but on the left it goes up 1, back 1, giving us that V shape. That's just y equals x, or absolute value of x. And, oops, I better call him his name there. This is the absolute value function. And the last one here is the quadratic. And quadratics always make parabolas. So he starts at the origin, it goes 1, 1. And remember, he goes 2, 4. That's why he's curvy. He grows fast. And symmetry gives me those other points. And it looks something like that. So there's our 4 parent functions. See, number 4 here, be able to graph a parent function and its transformation. So here's the function they want us to graph and its parent function. So I'm going to graph its parent function first. It's an absolute value. You can see those bars right there. And so absolute values go up 1 to the right, up 1 over 1, up 1 over 1, up 1 over 1. And if it was a line, then the parent function goes down 1 over 1, but all the y values get turned positive, so it goes left 1, up 1, left 1, up 1. It just does that same pattern it did on the right-hand side on the left side, going up and back like that. So there's the parent function. And it wants me to graph this one, twice the parent function, and it wants it shifted to the right by 3. So the first thing I can do is just shift him right by 3. I know he's going to start right there. Put him in blue. There's a shift right by 3 because of the x minus 3. And then it's all stretched by 2, so instead of going over 1, up 1, when I go over 1, it stretches the y value by 2 and doubles it to 2. And then because it's a straight line, that's essentially the slope. It's going, every time it goes over 1, it has to go up 2. Instead of going over 1, up 1, the stretching causes up 2s. And so my next one is over 1, up 2, essentially, right here. I get my pen to right. There we go. And so there's the right-hand side. The left-hand side has to mirror it, so it goes up 1, back 2, or left 1, up 2, left 1, up 2. There he is. Now, if I were a student, you know, I think I would graph my parent function on my calculator. I'd graph this new function on my calculator, and I'd look and I'd check out some points and make sure it all works out for me. Okay? That's essentially how you can do it without a calculator. And then number 5, don't worry about this one for tomorrow because we will be solving those on Wednesday to warm us up for our Thursday test on solving systems, or the second part of our test.